Okay, I always wanted to replace the CPU bracket, mounting bracket. The reason I want to replace it is because this AM5 secure frame V2 black bracket. Um, so this is right here. They say this is AMD AM5 ILM bending correct frame, and the reason why they say that they like this better is because it's a flat surface and you get better heat dissipation across the whole CPU contact to the CPU heatsink. Because if you notice this frame right here, it only locks in this right here. So it could cause it to bow. So basically, they say you can get a 10-degree difference in temperature with this bracket. So you would just unbolt these four screws right here, which I've already done, and it comes with its own hex bolt. So you can unbolt it, lift it straight up, and I think the screws, I don't think the screws will come out in here. So they're locked in, so they gave you 4 screws in there. So you just take the bracket. Now remember when we talked about pin 1, see that arrow there? And on our bracket, on our first video, we talked about pin 1. Pin 1, or that arrow always indicates pin 1 on any processor or any IC, any chip. You always look for that arrow and look for pin 1. And we know that when we looked at this bracket, the bracket was mounted this way. The bracket was mounted this way. Yes, the bracket was mounted this way, and when you lift it up, you see that arrow right there indicates pin 1. So you look for the arrow here on this bracket, and that's pin 1. And it'll only go one way. So basically, there you go. You can sit on there. And so you can see that it's a better even surface across the processor with this bracket. I always liked it, I admired it. It's better looking, better aesthetics. But the reason why the manufacturer doesn't do it is because the CPU has to go on first. Then they would have to send it out with it not mounted. And then with that bracket being exposed with all those pins, there's far more liability. But I think this is a much better method. So I will screw those bolts in. Okay, job all done. Now we just need to get the memory and install the memory. This light kit is basically pretty much the same as the memory, so I won't redo it. But when we install the memory, I won't give a lot of details because this is just for people that want to get into building computers, baby steps. I didn't give you a whole lot of detail, technical jargon. But when you buy your memory, you see this little key right there? One side is longer than the other. So basically you got slots right here. These little slots right here, your memory on both of them, basically you would just make sure that you locate it. I'll give you an example. So this is a light kit. I'm going to take this one out. And you press down on these tabs. And you'll see one end is longer than the other. And you basically key it up. You can't put it in upside down because if you put it in upside down, it won't fit. And you'll feel that it will not go in. So you just look for that little groove right there, that groove. Make sure that little key right there lines up with, make sure that little key lines up with the slot on the memory. And you just basically put it in that groove and that groove. And if they're lined up, you'll just press on it and you'll see it snap like that, and it'll snap like that at the top. And that's all you have to do when you install memory. But I know memory is sky high now, and I know a lot of people are used to paying for memory, and it did cost a lot of money. But when I used to work for a company called Humans Corporation in Beechwood, Ohio, and I'll do a video on that. So we used to repair memory. So basically, anytime you buy something retail, it worked. So when it fails, it's just usually a component failure. But when you work in a production environment, repairing memory or even motherboards, you send them out, you have them built, or you either build them in-house. But once you turn them on, some of them may not work. And you may not know why it doesn't work. And you have to figure out as a technician why the device didn't work, and you power it on. So if you look in here, you'll see these traces, right? So traces on the motherboard, when they're building these motherboards, the traces sometimes they will break because they're copper traces and they're so thin. So as the machine's laying out the copper trace, if it breaks, it creates an open circuit because it's not completed. Now, sometimes that copper will break off and fray and touch another circuit. That's a short. Then you have to find that short on the board, locate that short, cut that short, or then you have to find the open and you bridge that open. You take a piece of solder and copper and you solder from one end to the other. But that memory that I used to repair used to cost for like 1 meg, $200 to $400. That was for 1 meg. So I remember when it came out with 64 megs, I was like, wow, how much is that? So basically the company I work for, they will look at the proprietary memory that Compaq or AST and IBM made, and they would copy their memory and make a cheaper version. Their cheaper version usually meant we put more chips on a board because it was cheaper to buy more chips. But our problem was we created more noise and frequency. So ours wasn't as good as, say, a Compaq board. Because one time we got a Compaq board in, and I loved it because it was so beautiful. It was like this board. It was so clean. And ours had a lot of chips on the board, which created a lot of noise and caused issues. So when we look at these boards and when you basically have to troubleshoot them, a lot of times we would have component failures. So even though you had an open and a short or trace on the board, sometimes even inside the IC could it be an open or a short. So you had to sit at the bench and troubleshoot these components and determine what the issue was. Now, one time I had a person that worked in RMA, his name was Chris Andrews, came over and said, hey, we got this customer, he's complaining. He said, just blow him off. You know what, he doesn't know what he's talking about. So I was like, well, what is his name? Give me his number. I'm gonna call him and find out what the issue is. I called the customer up, and basically this was a Compaq 286. It was built like a tank. Back then, you can turn on a processor, you can turn on a computer, and you can put your hand on the CPU like that. All day long it would run. First computers, 286, did not come with a heatsink and fan on the CPU. But by the time they got to 800 megahertz and 1000, it would fry you. Even if you turned it on with a hot sink, even if you turned the computer on without a heat sink and a fan, you would see the vapors come up off the CPU and it would just fry it instantly. But anyway, I called that customer and I said, hey, what is the problem you're having? He said basically back then you can put memory on a motherboard, or they had a daughter card and you can piggyback on a daughter card. He said whenever he puts the memory on the motherboard, he didn't have any issues. It was only when he took that memory module and put it onto one of the daughter cards and piggyback it, he would have that issue. And I was able to replicate the issue, but couldn't figure out what it was. So I had to sit there and go by replacing each parity chip one at a time. It was a Vitalik. I replaced every Vitalik one by one with a Samsung. And basically, when I found out what the issue was, that resolved it. So I told engineering, but it was actually engineering's job to figure that out, but I had to do it. So we figured it out. Then the owner, his name was Marty Alpert. He took Vitalik to court and sued him because he had a lot of boards out there like that. Now, as long as the people plugged it onto the motherboard, no issue. But if they plugged it onto a daughter card, then you're gonna have issues. So yeah, that's what I used to do for years. I loved it. And that's when I got to really work at the component level troubleshooting. I didn't really work with anybody for years. I worked replacing and repairing memory modules. Okay, thank you. Have a great day. Bye-bye.